Hello everyone, welcome to the Introduction to Machine Learning course. So this particular video is about a very basic introduction, and people who are not already familiar with what is machine learning algorithms and how things work, this will give a small introduction of how and what are the algorithms and what are the actually the basics of machine learning. So yeah, we'll start. So what are the content today? We are going to see introduction, AI versus ML versus DL, artificial intelligence, machine learning versus deep learning. Then what are the different machine learning approaches? Then supervised versus unsupervised, classification versus regression. Then what is reinforcement learning? Algorithm for supervised, algorithm for unsupervised, reinforcement learning, and there's a conclusion. So this will give just an overview of what is machine learning in a just algorithmic way. So let's see what is machine learning in the first place. There is a traditional, there is an ML approach. What's the difference? The difference is in the classical approach there will be rules, then there will be data, and the system will give the answer. Let's say if I want to find whether the number is odd number or even number, I will write a code if that particular number can be divisible by 2 and gives the remainder 0, then it's an even number, otherwise odd number. So that rules we will be writing in a code, and when the data comes, our classic program will give the answer. Classic programming. So how the machine learning is different from a classic programming? Here we give the data and answer, and our machine learning system has to learn. So once it is learned, then it will tell the answer. So ideally it has to learn the rules. Let's say I give all the even numbers 2, 4, 6, 8 up to 100, and it says, see, this number belongs to class A, and odd numbers 1, 3, 5, 7, etc. It goes up to 99 and it says, see, these are the even number. I will not tell what it is. I have given the data, and I have given, and all the data I have given, and I have given their value also, the answer. So our machine learning model has to come up with a rule which is, these are odd number, these are even number, because of this. So the knowledge should be gathered from the data. So that's where the machine learning system comes. So usually when there is a large number of data and the hidden information are really difficult to identify by rules based, so that's where machine learning is more effective, especially in the big data field. Then what is AI, ML, DL difference? People are always confused. See, AI, deep learning, they think everything, all are same, similar. But the correct structure is represented by a Venn diagram. I can see it's a Venn diagram, it's a 3 subset. So artificial intelligence is a bigger circle, then the machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. So this is the Venn diagram representation of these three concepts. So the latest trend, everything is going on in this particular space, deep learning. So when deep learning becomes high, people will obviously see it's artificial intelligence since it's a subset. Yeah. So this is like a big picture of what are the machine learning algorithms and what are the approaches. If you see machine learning, there's a classical learning, unsupervised, supervised. And in supervised, I will explain what is this, and there is a reinforcement. In supervised, there is a regression, there is a classification. Then in unsupervised, clustering, pattern search, dimension reduction. And in reinforcement learning, this is a separate field than supervised and unsupervised, because it involves environment, agent, penalty, those stuff. Means if you do good, I will give you credit. If you're not doing good, I will penalize you. So that's the idea. Then there is a neural nets. This is a guy, who is this neural network is the one is trending nowadays, because it just solves all the problems. All other things are failing, are having a hard time to solve. And deep, convolution network, recurrent neural, GANs, autoencoder, perceptron, all comes in with it. Then there is an ensemble. Ensemble is just stacking of 2-3 algorithms. So this is a overview of it. So I will just explain what is there. So any basic problem if you take, it comes and a machine learning problem, it comes under two. Either it is a supervised or unsupervised. What is that? Supervised means you will be having a label. Unsupervised, there is no label. So what is label? I give an example: 2, 4, 6. It's an even number. 1, 3, 5. It's an odd number. So if I tell these both information to my model, see, these are my data, these are the labels. 2, 4, 6 are even number, 1, 3, 5 odd number. If I tell this and ask it to learn, that's a supervised learning. In unsupervised, I will not just give anything. I'll just give all the random number and I will say, hey, just split into 2. In that case, it will not split into odd or even number. It will split into, let's say, above 50, below 50. Maybe it will split into number which are decimal, which, let's say, 2.5, 3.5, all those. I mean, that's unsupervised. So the main difference is supervised. There will be a pre-categorized data, meaning I will give the data and their label. But in unsupervised learning, it's unlabeled data. I will just give you the bunch of data and ask it to do the clustering. So these are the two basic. What are the examples? So classification. Let's say identifying the fraud detection, or you can say whether the email you are getting is a spam or not. So already the model has been trained, if these are the these are the spam, these are the not spam emails, learn it. The next time when there is a new document email comes, it will just say either it belongs this or this. That's why it is a classification, just classify into this side or this side. Then there is a regression. So what is regression? Regression is like imagine stock market prediction. I will give you what happened in the last 1 year. You tell me what will happen in the next tomorrow. So it's like a extrapolation, you can say. So this is a forecasting. Market forecasting is example. Then unsupervised. Here in both case I have given the label, meaning data plus label, and you have to learn. But here I am not going to do anything. Let's say clustering, targeted marketing, association, dimension and detection, big data visualization. Here, instead of telling what to look for, it will actually identify the pattern by itself. So objective is prediction and predictive models. Here there is a pattern. Then supervised learning. So again, example, see, this is the label data, this is the data and their labels. I will say this is hexagon, this is square, this is triangle, and using with these two information my model will learn. Once my model is learned, and when I give the new data, it has to tell whether it's a square or triangle or hexagon. So when I give it to the learned model, it will predict either it's a square or triangle. So this approach is supervised learning. There will be a data and their labels. Imagine if I don't give this, this is hexagon, this is square, still it will identify, try to identify this, but that is called clustering, not, I will explain that later. So supervised learning, label data and their label, and the model has to learn from it. Then once the model is learned, then when I give the data, new data, it has to predict. That's supervised. Then how is unsupervised works? Here I will not tell this is orange or apple. I will just give, see, these are the 6 pictures I have. Just cluster it. I don't want to know what is this. Just cluster it into 3 sections. So our model will interpret this. Then there is an algorithm. Then it is processed. Once the model is trained, then it will just able to classify 3. Here we may not know on what basis it cleared. Maybe it just saw the color. Okay, look, there are 3 different colors. I will categorize this way. Let's say if I give the yellow color apple, let's say I just paint the apple with yellow and I give, most probably it will put into yellow, maybe, because it's a clustering. We will not know on what basis algorithm has clustered this into 3 categories. So that's the difference. Here there is a raw data and the model will learn. So what's the difference here? Input data and these are the apples. In supervised learning, I will tell both. See, this is a data, this is an apple. Then model will learn. So next time when the model sees an apple, it will say it's an apple. This is called supervised. Unsupervised, I will not tell anything. I will just give this bunch of data and I will say just group it into 3. So it will look okay, these all look similar, these all look similar, so it will just put it in a 3 different groups. This is clustering. Again, here we don't know whether it is based on the color or based on the structure it is clustered. Same example, if I give the yellow color apple, most likely it is going to put it here in yellow category because it's an unsupervised and it is just grouping, there is no target available. So how it works in the space, like if I plot and see there is a supervised, there is a red color, I will say imagine initially there will be red and green and blue. So and I will say, see, I will give it to the model and I will say, hey, these are my 3 data, just make a boundary line. So, and this is one nice example. Let's say there is a flower and petal length, petal width, and the based on the length of the petal and the width of the petal, and I will say if it is this, it belongs to red. If it belongs to this, it is violet. It belongs to this, this. So these data I have given during the training set. So once I give the training set, only the supervised model has to identify this boundary. So once that's what the learning is. It's just function approximation. It identifies the boundary. So once it knows the boundary, next time if I give the data, like say flower which has okay, after standardization -1 and 1, let's say this point I never given any training data, but algorithm has decided this is the boundary, so it will most likely to say this belongs to red category, and if it comes this region, this belongs to this. So this is the boundary separation. The whole idea of supervised learning is finding the boundary and how much you have to take for the which are the features you have to consider. What happens in unclustered? So look at this one here. This is the data I'm going to give. I'm not going to tell this is this color, this is this color. I'm just going to say these are the bunch of data, just group it into 3. Okay, if they if I ask you to do, what did you do? Okay, here I can put one circle, this I can make it one group, this I can make it one group. That's what algorithm does. It just say these are red group, these are blue, because they are close. Just you can think it is a nearest neighbor. Okay, these people are close, and to find the average centroid, it will come somewhere here. Centroid will come here, centroid will come here. So this is unsupervised. So in supervised I'm going to give the label and the target. There is 2 types: classification, regression. Classification, imagine you just have to tell it yes or no. Is it a spam or not spam? Is it belongs to class A or class B? In regression, you have to predict. Let's say if it is 70, what will be my let's say stock? If it is afternoon, what is my stock? You have to tell me this. So in classification, we have to identify the boundary, so that if it falls this side of the boundary, we can say one class. If it goes this side of the boundary, we can say it belongs to other class. In regression, we have to identify this line, curve fitting. You can see this is a line, the best line which can fit this line. So these are the main 2 branches of supervised learning. Then what is reinforcement learning? Reinforcement learning is what I said. There will be an environment. You can think of it this is like a game playing environment. Let's say this is a game. There is a maze solving game, and the agent is say there is a bot. It's going to take. I will leave the bot somewhere here, and the bot has to take an action. Either I have to go right or left or straight. So it will take an action in the environment, and it may win, it may lose. If it wins, I will give the reward. If it loses, then there is a penalty. So the whole idea is this policy evaluation. So the agent has to learn what action should I take so that I can get more reward. So that's optimization problem here. This is called reinforcement learning. So again, the same example. See, there is a rate, and at what rate it can go, what temperature. So these are the parameters, like what is it. So based on that, it has to take the action, what or how fast it should run. Then once it succeeds, it will get the reward. Then it will most likely to do the same. But if it fails, we'll penalize it. Then the observation will go. Then it has to take the other step. That's reinforcement learning. Now SVM in supervised learning. Supervised learning, we know there will be target, there will be two class or many class. So we just have to tell it belongs to class A or class B. Look at this example. Feature 1, feature 2. Feature 1, feature 2 is like some parameters you can consider. So here they are telling these are all black, these are all blue dots, these are red dots. Let's say if it is 0 to 5, if it is 0, 1, 0, 2, 0, 3, all these are coming in a red, these are blue. Now in supervised learning, when they give this, all we have to find a classifying line, classifier. Yes, we can draw this line, but I can draw multiple lines that can separate this. Let's say I can draw a line like this, which is parallel to this. So out of all the line, which line will have the maximum separation between the two classes? That will be identified. That is called SVM, support vector meshing. So the points which are closest to the line are called support vectors. So what's the idea here? There will be two data, linearly separable data, means you can draw a line in between them. Let's say if there is one blue dot here, you cannot draw a line. And if there is a line you can draw, and there are multiple lines you can draw, out of all the lines, finding the best line which have the maximum separation between these two classes. That's SVM. This is the SVM algorithm, support vector meshing. Then there is another algorithm, K nearest neighbor algorithm. So look at the example here. There is an x-axis, there is an y-axis. These are the red triangle, these are the red stars and green. These are two classes, and now I have to identify the boundary. So instead of identifying the boundary, I can just look around. Let's say there is a new data point coming. This is the one. I want to know if the new data point comes here, should I put into this or this? The best way to identify this is just count how many people surrounds you. If you say k equals 3, find the 3 closest neighbors. Let's say 1, 2, 3. Out of this closest people, out of this 3, 2 is red, 1 is green. So it will most likely to go into this class. This is k nearest neighbor classifier. The idea is simple. We need a boundary, but here there is no boundary. But when the new point comes, I will look around my neighbors. Let's say if the new point comes here, let's say here, where is my this dot is there. I will look around how 3 neighbors around me. Let's say 1, 2, 3 neighbors. Then if all three are telling it's green, then most likely I belongs to green. Yes, that's what K nearest neighbor algorithm is. Next, there is a decision tree. Decision tree uses a tree structure, top to down. So here what's the idea? I will, let's say I have 5 parameters. I will check parameter 1, then I will choose either this or this. Then parameter 2, I will decide parameter 2 this side. So at the end, the leaf node will have the decision. So how it works in the big scale? There is a labeled data, decision tree 1, decision 2, decision tree. So each says certain classes. This is a random forest actually. So each tree will tell, okay, your point belongs to A, your point belongs to B, your point belongs to C. Then everything should combine and will take the vote and will take the final class. So this is a decision tree based algorithm. Then our favorite simple neural network. So in neural network, the idea is the boundary will not be decided by us, because in the last SVM I said it has to be linearly separable and I drew a line. The question may come, why it has to be a line? Why not some kind of curve? Maybe some cubic curve, maybe some parabolic curve where you are considering it. Yes, it is possible. And that's why neural network comes. Neural network will identify the pattern with the hidden neurons. These are the neuron. Each one is a neuron. This is an input layer. This is an output layer. And each neuron will be activated for certain points with certain features. So if it belongs to one class or other, output layer will tell. So in the SVM we drew a line, but here there will be a complex structure which gives a boundary. We will not know the boundary. So that gives a huge power to the supervised learning algorithm, because if I say it's a linearly separable, if I say I have to draw the line, I'm restricting myself. Maybe if I use second order equation, I may get better result, but no. So maybe third order, we never know. That's why neural network comes really helpful. The idea is minimizing the function. This is one good name. All your model has to identify a global minimum. If you can achieve it, then it's really great, but most of the cases we will not reach the ideal global minimum. We will end up at the best local minimum we identified in the error surface. Then linear regression. Let's say simple example. I'm in the last 10 exams I'm noting. If I study for one hour, I'm getting only 20 marks. 2 hours 30. So I'm noting down all the hours. 9 hours means I'm getting 19. So in all these data points I know, how many hours if I study, how much marks I'm going to score. So once I have this information, now I can use a linear regression. So I will give the model to predict, okay, I'm going to study for 6.5 hours. What's the most likely score I can get? So for 6.5 hours, you will be most likely to get this point. Okay. It goes here, so somewhere around 70. So this is a regression problem, linear regression. That same you can use it for, in the high level there is a stock market, they will decide when to sell, when to buy. If the stock is going really, really high, buy. This is how the real world application works for the linear regression. Then where they are using, okay, we saw linear regression, but where are we using it? We are in a supervised section. There is a data, there is a label, from that you have to learn. Then there is a classification and regression. So where a classification, spam filter, when you get a mail, it has to say whether it's spam or not. Then language detection, when you give the language, it should identify out of all the 100 languages which language it is. Then search for a similar document. That one we can document classification. Then sentiment analysis, either I have to, when I see the text, I should say whether the person is sad or happy, or I think 6-7 major sentiment is there. I have to identify one of that. So that's a classification problem. Then recognition of handwritten, okay, characteristics and number. Okay, let's say 0 to 10. The way I write the number 2 is different from other people, right? So it's a really good classification problem. Then fraud detection. Let's say there's some bank transaction, let's say other side of the world, somebody trying to access your account, most probably somebody fraudulent is trying. So these are the application of classification algorithm. Then regression means what? Regression, we have to find the boundary and classify. Here we have to do the fitting, curve fitting. Just keep it like that. Here stock price forecast. Yes. Then sales volume analysis, medical analysis, time, number and time correlation. So all this to calculate from the regression. Then there is a clustering. Here I will, the clustering is unsupervised, so there will be no labeled data. I will just give the input and I will say just cluster it, meaning just group it. Imagine I'm going to give all the balls and I'm going to ask the model to cluster. Most likely it will cluster this way given. Instead of 3, if I ask cluster into 2, maybe it will put all this 2 into single category, and it will put single class, single group, and it will keep this as single group. Here the difference is, yes, you may look, it may seem both are same, but the difference is, if I give an yellow color soccer ball, most likely it will put here, because we don't know what are the factors it is looking for, because it just see the patterns. Okay, you all three look similar. Maybe it just look at the color. Here there is a black and white, then it goes here. Then there is a white with red, it goes here. Yellow with black, it goes here. So next, if I give the yellow, yellow with white, let's say instead of here I give yellow and black, instead of keeping it in a soccer ball section, it is going to keep it here. So this is a clustering algorithm. It's really helpful in certain place. Where we are using is market segment, type of customer analysis, close point merge, image compression, yes, in the image compression, and abnormal behavior. Yeah, let's say all this, yes, outlier detection again. Then k-means clustering. So how it works? Before k-means, this is the bunch of data. There is no cluster, and our model will tell, okay, I'll see the data. All these are a little bit close. They are a little bit close. They are a little close. So it will just put these are the three group. This is k-means. In k-means, it will identify the centroid. Let's say here is a centroid, means if you just average out these points, just maximize the distance between these two guys. So centroids. There you go. That's what you do. Then there is a hierarchical clustering. Now, what is hierarchical clustering? Clustering visa, I give a bunch of data, you put into three categories. But hierarchical, there is a whole data, and there is the whole data can be under the two segment, and each segment can be divided. So this is a good example. There is a main, which we can divide into two. All the data we can put into two. But still, in this one, I can again split into two. So instead of having all the root, I will have the hierarchy of cluster. This is really helpful when let's say you have to arrange the books. Maybe some books goes here. Let's say this is fictional, this is academics, and in fictional there will be different section based on the authors, based on the I don't know what else is there. Let's say horror, romantic stories, so all these different categories. Here also, in academics, different computer science, machine learning, aeronautics, aerospace. All this hierarchical analysis can be done with hierarchical clustering. Then there is a Gaussian mixture model. So what is Gaussian mixture model? It's like getting a, let's say there is a, okay, this is the example you look at this. This is the data points, this is the data points, this is the data point. So mixture of these three will be represent this three, atomic, three-dimensional. Again, this one based on the probabilistic model. Then there is an outlier detection. Let's say, you always access your bank account only from two cities, either from your home network or from your office network, let's say. And suddenly out of nowhere somebody is using it outside of your country, then most likely it's something wrong with it. So this is like outlier detection, finding the unusual behavior. This is just an example, or this is just one unusual. So this outlier detection is a part of unsupervised learning. Here there is a bunch of data, there is a bunch of data, we can cluster it together, but this can be an outlier. So this is local outlier factor detection. Then there is a neural network for clustering. So it's a neural network can be used both for classification, regression, clustering. He is an all-rounder. He can work all the fields. So here is how it works. There is the input data, there is a neural network, then there is a softmax. At the end of softmax, it will say cluster 1, cluster 2, cluster 3. So using these, the similarity pairs we can identify. See, if we see data 1, data, again the same goes how we work for the clustering problem. Only difference is here there is a neural network which optimizes the model. That's the only difference. And again, there is a big architecture. What are the things, if you dig deep, you'll get more and more. Then there is an autoencoder. Autoencoder, let's say here is an image, and to reproduce the same image, you can see it is in like a compression. Let's say here is some 256 or 256 image, and that I'm compressing up to only with 4 pixel. Then I'm regenerating to get this one. So if I can get the same picture with 4 pixel, it's really good, because I don't have to store all that. I can just store these guys. This is called autoencoder. The idea is it has to identify this one. Usually this one used in embedding, as an embedding. So once you know this one, you don't have to keep the full. So to generate this one, autoencoder is used. Okay, now comes the best part, reinforcement learning. Let's say people might have come across AlphaZero, AlphaGo, or the chess playing bot, Atari bot, the bot which can beat humans. Everything runs on reinforcement learning. There is no supervised learning. It's a reinforcement, meaning you have the goal, and if you can succeed it, you will get a reward, otherwise you'll get a penalty. That's what it is. There is a task, there is an agent, and there is a skill. Initially there is a student and teacher, score and the task. Then what happens? This is teacher student. Then there is a self-led, 2 players, he scores. Then there is task, score, task. Then there is a goal discriminator. Okay. Then skill extraction listed. So these are the different kinds of reinforcement learning setups. And the one which the basic you should know is Monte Carlo. Monte Carlo is let's say this one. There's a 3 sample state. If you want to let's say you have to get some more diamonds, what's the optimum path you can take to reach this? If I can go this way, I can go this, I can just roam around like this. So the optimum path, so there is a reward written to 33, 15. So the goal is to get more of this. So our system has to identify which action should I use so that this is the reward function should be maximized. That's a Monte Carlo example. Then there is a deep Q learning. In deep Q learning, where are they using it now? Okay, in self-driving car, not just a deep Q learning, it's a combination of all the possible deep learning you can think of. They have image, everything. Then there's robot vacuums, games, automatic trading, enterprise resource management. Reinforcement learning has been used in all the places. So this one is a famous Atari game. Let's say this is an agent. So what are the controls an agent will? The agent is, think about, it's a bot. Either you go right or you will go left. What are the information you have? You have the information of where the ball is. So if the ball goes here, it most likely hit and come back with the same angle. So I have to stay here. So initially when the model try to learn, it will not do that. It will just randomly move and it will go keep on leaving the ball. So at some point it will learn, okay, to catch the ball I have to do something about it. So then it will identify the pattern. Okay, this is how it is coming. Then it will start to play well. Once it plays well, then eventually it will identify, okay, I have to hit the corner so that my ball goes here and get it. So this is a process. You have to train the model to identify this. It's a time consuming and hugely application oriented. Then there is an algorithm cheat sheet. What are the algorithms which can be used in general? This is from Scikit actually. If you have the number of data sample, what are the things you should do? This is you should take a look at this. These are the classification algorithm. These are the regression algorithm, clustering, dimension reduction. And in dimension detection, let's say if you have less than 10k, you should use this, otherwise don't use this. And again here, naive Bayes, when to use linear SVM, when to use SGD, these algorithms. So each algorithm, has its own pros and cons. You should know when to use which one for the good performance. So this is at the end. This is the I hope I give you a little bit of introduction about what are the algorithms and why we use them. So in classification in general, this is how the pipeline works. Let's say there will be training data under the label. Again, it's a supervised learning. From the training data, they will extract the features. What do you mean the features? Let's say I have to identify it's a car or a tree. Car means most likely I'm going to see the wheels. Tree means it will be greenish. There's such a good features. These features we need to extract. Let's say if you want to identify the sentiment, if there is a bird, something like crying, I know it's a sad. So those features are important. So these feature extraction is very essential before giving to the model, because the performance of the model also based on how good your features are and how good your training data is. So here you should take it with it. So once the feature is ready, once the data is ready, we will give it to both of them will be given to the machine learning algorithm. So what algorithm to pick, which algorithm to decide when to use, all this it's a problem dependent, not like one will solve all. So this one also you have to decide. So once the machine learning model is ready, we have to evaluate the model with some of the test set, so that I will know okay, my model is doing good. I will change my algorithm, evaluate. I will change my feature, evaluate. So this is the training process. So what happens during the training is, there is a data, there is a label, there is some feature you extract, do the things, model, see the performance. If it is not good, change the feature, see, not good, change the feature, not good, change the feature, not good. Then change the algorithm. Okay, maybe instead of case nearest neighbor, I should be using something else, SVM maybe, or neighbors for this particular problem. Change this, evaluate, not good, do it again, not good, do it again. When this whole process is done, at the end you will be having a model which is performing better, which gives good result. Once your model is ready, then when the new data comes, whatever feature you extracted here, you have to extract from here, and you give it to the model will predict the label. That's it. Let's say you give the data and you say this is I know this is the label, learn it. Once it's learned, next time you just have to give the data, it will tell you the label. This is the whole pipeline of the classification. So once you understand this one, how the basic thing works, then everything else comes forward. You can just dig deep, whichever algorithm or whichever training set you want to work on. You can use it for image, you can use it for text, you can use it for speech, you can use it for 3D image, linear. It's really huge opportunities, and also development research is going on, so you should take into the consideration. Thank you very much. And any questions if you have regarding, say, this is a very basic introduction, and each algorithm is having its own math supported machine learning algorithms. Like SVM is math heavy one. Then there is neural networks, which is full of architectures like RNN, CNN. Then there is GAN, there is all that. Then all the images I have taken from googling, some open source here and there, so I should give credit to them. So these are the image credits I can look, and I will just put give the PPT in the description, you can if you want. So so this is the one. Only if you can just keep this in mind, it will be really helpful. Machine learning algorithm, supervised, unsupervised. Reinforcement is a neural network. Neural network can be used for this. Like he's like a superhero. Anywhere he can be used. Just if you have the labeled data, go for supervision. If you don't have the labeled data, go for unsupervised. If you have something like do this, you have to play this, you have to maximize something, reinforcement. In supervised you will be having the label and the data. So when you have the label, either it's classification or regression. In classification, what are the classification? You just have to identify the boundary. So the whole idea is to get the boundary line between the classes. K nearest neighbor, naive Bayes, support vector machine, decision tree, logistic regression. All these are major. I mean, there are tons of other others, and the derivatives is let's say SVM. There is a kernel SVM, decision tree, random forest, logistic regression. It just goes on. Then in regression, linear regression, polynomial regression, rigid and lasso regression. Then there is another section, regularization, how the regularization should be done. Then there is a trend analysis. All those stuff comes here. Then in unsupervised, if you come across most of the text related problem, it will be unsupervised. If you, I would recommend you to watch, like a Hugging Face repository. They have the state of all the models, and because it's really tough to get the label, it needs a manpower and accuracy, all those stuff. Because if your label is not good, your model is not going to perform well. So unsupervised clustering, K means, parameter, mean, shade, fuzzy, then pattern, IPR, FP growth, then there is dimension prediction, TSNA, PCA, SPD, all those stuff. Then pretty much. Neural network has a bunch of convolution neural network, recurrent neural network, GAN, automatic. So I think that's pretty much I covered. So thank you very much. If you have any questions or any comments, you can just leave in the comment section. Thank you.